is Harold Thimbleby, whom I will introduce because he was my master's master. I'm very glad to see him here.
Well, thank you very much for inviting me. I'm going to tell you something I'm sure you know, so I'm not trying to be condescending. I want to tell you something you know, but I want to engage you with it so that you enact it, so that you start looking around for where this happens. I'm sure you know the word reification, turning an idea into concrete. This is an idea turned into a lump of granite. And the idea is when things are written in stone, you don't change them. And sort of the opposite of reification is, I don't know, there is a word, because we don't do it very often. To turn an idea into enacting and empowering so that you get inspired and do something. So, I'm going to tell you something completely obvious, but I want to encourage you. This is, the opportunity is around you everywhere to think computationally, right? And when you put it in stone, it stops the computational thinking. And of course, I'm sure you recognise that's the Rosetta Stone. It's about 2 metres high, 1.5 tonnes. It's a huge, well, I mean, the Rosetta Stone that we know now is just a chunk out of a bigger document. And coincidentally, it's about 2,222 years old today.
Oh.
And it has the language of the gods, which of course you can't argue with. And then the language of the documents, so that you make sure priests write it all down, so that you can't argue with it. And then the language of common slaves, so that you get on and do it. That's the idea of the Rosetta Stone. Of course, we now know, we've now given these things different names, the hieroglyphics, demotics, and ancient Greek. And somebody noticed these are parallel texts. They all say almost the same thing, and then you can start decoding hieroglyphics and demotics because we knew how to speak Greek. So the parallelism gave us a computational thing to decode something that had been a mystery for about 2,000 years. This morning I was having breakfast, I'm sure. So these are concepts you're all familiar with: NMS, Xanadu, intertwinkling, alts. A lot of it is about having original text, making links or copies, and you just end up reifying stuff in fascinating ways, because it's reification rather than empowerment. Have a look at a modern book. I'm writing a book. This is the next book after Press On. This is called Fix It, or Fix IT. This is standard stuff. When people invented books, they started handing them out to their students, and they would say, turn to page 175. There was no point having page numbers until there was a printing press copied, because if you had a monk write everything out, they wouldn't preserve the page numbers. And then you get page numbers and you start realising, well, you can have a table of contents, and you can have an index, you can have running heads so you know where you are in the book, you can have footnotes, the figures can be numbered, and in fact the printing press changed how figures were done, because you'd never trust a monk to draw a picture, but once you got woodcuts, the figure gets reproduced reliably, and you end up with endnotes. And this book's got your eyes in it, so you can click on it and it will take you somewhere else. This is stuff that is going on, and we take it for granted. It's all completely trivial stuff. Page numbers, I'm sure you can count 1, 2, 3, and that's all you have to do, and just put the page number in the right place. Okay. How about this view? To write a book like this, I'm lazy, I want to do as little work as possible. I want to say it once, or preferably less than once, because I'm a programmer, so I can generate stuff. And then I want to share it many times, like I'd like you all to buy it, and I'd like the world to buy it. And in fact, you could say there's a sort of computational leverage. How many shares am I getting for the amount of work I put into doing it? And of course, computers increase this enormously. You compare the amount of work I did on this to the guy who carved the Rosetta Stone. And this is going to be the outcome. I'll just say quickly, I'm not going to tell you about the content of the book, I want to tell you about the structure, the computational structure of the book, but I can't resist just advertising it slightly. Do you know what you're going to die of? Top 3 killers? cardiovascular cancer, error. And computers are everywhere in hospitals and primary care, and the polite word is they're fucked up, and this is what the book's going to sort out. And it's got a table of contents. Part 1, heading for part 1, heading for the chapter, and so on. This is all familiar stuff. Almost every book does this. And if I go into the book, this is chapter 12 on computational thinking. The stuff I've highlighted in red, I actually wrote somewhere else. And my computer programs moved it into the places I wanted. So, for instance, the part title is down the side, and the number of the part is 2 bars that bleed off the edge of the paper so that you can see where you are, so you can navigate around the book easily. So that is all automatic, and this stuff is text that I copied from a book somewhere else, so that's been pulled into the book. This is obvious, isn't it? And then there are endnotes, and the stuff there, my programs wrote, I didn't do. I mean, sort of, obviously I did it, but I wrote a tiny amount compared to the 300 notes that are in the book. And in fact, all of those notes, there's one of them, I wrote that somewhere else in the book, and the computer moved it around. We take this for granted, don't we? How about this obvious comment? Unnecessary distinctions are bad.
Yeah.
Why should it matter where you say things? And it matters a lot where we say things in almost every system we use. So, here's my table of contents, and there is some pages inside the first chapter starting off. And like many authors, I wrote the chapter, and then the cunning program, could have been Microsoft Word, happened to be LaTeX, takes the chapter title, which I wrote over here, and puts it in the table of contents. But because I wanted to get the through line sorted out, I wrote these texts in the table of contents, and then, whoops, this is great, isn't it? And then the table of contents was moved back into the chapter. So the text isn't just parallel, linked, and so on. It is what I call equal opportunity. Wherever the text is, it has an equal opportunity to be part of the book. In a conventional document, in conventional hypertext, you have an original and a link, maybe, and a copy. And if you want to change this, you have to change the original. In my book, I can change it anywhere. So, here's an example. I knocked this up on the train down from Waterloo yesterday. It took me about 25 minutes, but I can show you. It's a 2-chapter book, table of contents, and sort of 3-4 pages in each chapter. The chapter's got running heads. They've got a title, and the title ends up in the table of contents. But this is trivial. But once you think of it, if I fix it in the table of contents, the headings change. And if I change the running head, everything else changes, like this. The running heads, the chapter titles, and the table of contents have got equal opportunity. And if I happen to be looking at this and decide this is the wrong chapter title, I can change the running head, and the whole lot changes throughout the document. Of course, this is just a few minutes on the train, but other people, like Google, have done a better job than me. This is a Google Docs paper I'm working on with a friend, and he's writing it as I'm writing it. We have both got text we can edit. There isn't an original and a copy. It's got equal opportunity. And I've thrown in a table of contents, and as we fiddle with it, the table of contents changes.
2 minutes.
Cool. These ideas solve lots of problems. This is a paper I produced last year. We're all worried about reproducible algorithms. This is an equal opportunity to make reproducibility much easier. This is a copy from the middle of the paper, and the paper generates a C program, and the C program generates parts of the paper. This is easy to do, and if you look at it like this, there's the word, well, I wrote this with an anaesthetist who wanted to do experiments with the order in which you give people anaesthetics, but we thought our readers wouldn't understand fentanyl and so on, so we changed it into common wines like Merlot, Pinotage and Shiraz. And you can see the word Pinotage, you can see the word Pinotage there in C code, which is executed, and then it appears typeset down here in several places. It's all done automatically. this means if I decide pinotage is the wrong wine to talk about, I change it and the whole lot sorts itself out. That means the code in the program is actually the code I used, rather than some fantasy, which is one of the hazards behind reproducibility. And to print the program, print the paper, I had to run the program. Right? So it's a sort of hurdle I set myself, I had to overcome. This is reproducible, that code actually generates that. So you've heard about intertwingling, and in the example I've just shown you, there's a C compiler and processes and stuff, and it intertwingles the text. Why not have some computational process there that does something more exciting than just copying and pasting? So, to summarise, started off with stuff written in stone, and then you can share stuff in silicon, and it becomes much more exciting and powerful, and we get excited. But why not think about the computational leverage? You can do something better than just sharing it. You can transform the text, and you can make it. You can set up a relationship so it goes in both directions. And then, just to finish, the reason why this is worth doing is because it changes the world. Stuff was written in stone. The phrase "written in stone" means you can't argue with me. Right? It's a power game. Shared in silicon, if that's how you want to put it, is a power game. For example, my university buys a bloody computer system and says, you will start using this. And it changes my life. And when I say this is a stupid system, they say, well, we've bought it now, we can't change it. So they're sharing stuff which is not changeable, even though they're using a computer to mess up everybody's life in the university. But when you give the people who have got the documents computational leverage, you're playing an empowering game. That's what I'd like you to do. When you see documents, how can you use the computer to empower the reader to transform the world?
Thank you. Les.
Okay, a really irritating question. Sorry, I can't help thinking that. I think, oh yes, I remember what it's like playing with latex to get raw computational power. You start to, when you include a piece of code, perhaps you'll include a package from somewhere else that you need to cite, which means that you generate something else that has to be embedded. How many times do you have to run LaTeX, and how do you know when you have actually satisfied everything, everything's converged onto a finishing state?
It's a standard thing to get the cross-references and stuff right. It's twice. And I've got a makefile that does the whole lot for me. So you're writing your document where you've got code and text all mixed up, and you think, oh, it would be nice if I changed the spelling of the wine or something. And you do that, and you press something and it makes it, oh, I'll redo it, and there it is, done. Let me show you.
Good.
Yeah, I mean, in the example I showed you, it's a sort of Unix tools approach, and you have to be cunning to do it. But the idea I want to inspire you with is when you start thinking computationally on parallelizing text, you empower the user. And the reason why we've got a reproducibility problem is because writing text is just such a nasty, well, as you say, running latex is such a nightmare. People can't be bothered to be honest in what they publish because it's such an effort to do it. So you copy and paste a bit of code into your program, and latex has already got a backslash there, and buggers. So you have to change things, and when you change things so that you can publish it, it's no longer what you're actually executing. What system solves that problem?
I think that a number of people do this, and I'm slightly scared by the fact that my own writing system is practically identical to what you've described, just done using slightly different languages. And I think there are quite a number of other people I know who've also written their own systems to do almost exactly what you described. Perhaps we should all get together and do something with it. The principle has worked and has occurred to many people simultaneously, but we don't seem to be talking.
Jupyter notebooks?
Sorry?
Jupyter notebooks, have you come across?
Yes.
Yeah, because that's kind of like a general, well, I suppose it's a Python.
Well, these are, as I said, these are all ideas we know. What I want you to do is to think these ideas can empower people. How can we use a computer to empower people, rather than like my university or the hospitals I go into? The computers are used to screw people, and you have to do what the computer says. It's insane.
It's a brief one. Yeah, just quickly, it's a question. I find this quite nice. I'm very frustrated with tools for teaching coding to children, because it teaches them something that's not really what they ultimately need to know. But in this case, they spend a lot of time also learning to write, and I think teaching code in situ with actually telling stories might be, is there any of these tools that have been developed that I don't know about that are more or less designed for children?
That's a good question. So yes, well, I was trying to empower you, but any important question is going to take like 30 years to sort out. It's going to take 30 years to solve any problem in the world, like Brexit or whatever. If it's going to take 30 years, we have to start with children.